Today I am going to talk about an interesting topic that relates to substitution and elimination reactions. Usually students face considerable problem while deciding whether a particular reaction will generate a substitution product or elimination product, or both product will be formed. So in order to resolve the problem, we will focus on some rule that will help us in deciding whether a particular reaction will generate which product. But before addressing those rules, let's first focus on some example so that we could get to the problem or confusion how we get different product while we are not in a position to decide which one will be dominant and which one will be minor, or whether a particular reaction will generate a single product or multiple products. So let's first focus on some example. We have tertiary butyl iodide, and we subject it to react in the presence of sodium methoxide. We get a single product of alkene through E2 mechanism. Similarly, in other case, we have a molecule of 2-bromobutane which is subjected to react in the presence of sodium hydroxide. We get different products such as trans-2-butene, cis-2-butene, 1-butene, and one product of substitution in which the OH group is below the plane. So in both cases we have a different distribution of product. In first case we have just only one product, but in second case we have a different product. Usually alkenes are formed through elimination reaction, where substitution product depend upon the type of nucleophile. So in the second case we have hydroxyl nucleophile or hydroxide which act as a both strong base and nucleophile. Therefore this is substitution product. Whose stereochemistry tells that it is formed through SN2 reaction. So here is a confusion whether elimination product will dominate or substitution product, or whether which of the elimination product will dominate, because this is cis, this is trans, and this is a terminal, a double bond. So in order to address this confusion, we will focus on three important rules. But again, let me present some more examples. Here the starting material is tertiary alkyl halide, which is reacted in the presence of a solvent such as methanol. It enhances ionization and gives a carbocation like this. Which can be attacked by the solvent, and we can get a product like this is FN1 product. Similarly, we have hydrogen over here that can be abstracted by the base or the solvent which act as a base, and we can get an alkene through E1 mechanism. So which product will dominate depend upon the nature of alkene. If the alkene form is tri substituted or tetra substituted, then the elimination RE1 will dominate. So here in this case E1 will be a major and FN1 will be a minor product. So this will be major because the double bond is a tri-substituted. Let's take another example. Here as compared to methanol, which is weak base and weak nucleophile, sodium ethoxide is strong base, and strong base are needed for promoting E2 elimination reaction. So these reaction will generate different products such as these. It can be cis as well, and one substitution product. So this is trans, this is terminal, this is cis, and this is substitution that obtained through FN2. So again, if the base is stronger, therefore the trans product will dominate and it will be major, unlike the substitution product, because substitution reaction at secondary or tertiary alkyl halide are hindered because they are not a good substrate for FN2 reaction. Whether there are secondary or tertiary alkyl halide, both are not good substrate for FN2 type reaction. As far as the terminal double bond is concerned, it is unstable. Similarly, a cis double bond is also unstable. So this trans product will be dominant or major product of the reaction. Let's consider another example. Here ethanol is again a weak nucleophile and a weak base. It acts as a solvent that will enhance ionization, and we will get a carbocation over here which will rearrange where the ethyl alcohol will attack, and we will get a product like this. This is through FN1, and one product will be obtained through elimination reaction as well when this hydrogen is abstracted by the base ethanol, which acts as a base. So here again, whether E1 or E2, which one will be dominant. So as ethanol is weak base, therefore it will facilitate substitution reaction rather than promoting elimination reaction. So this FN1 product will be a major product. This will be major. Let's check another reaction in which starting substrate give different product A, B, C, D and E. The first two products are substitution, where the later three products are elimination. As methanol is a weak base, therefore it will not facilitate elimination reaction. So this elimination product will be minor, and as far as the substitution product are concerned, so at this product is obtained through Fn2, not Fn2 but in Fn1. Well, this substitution product will be obtained through Fn2, and we know that Fn2 at secondary substrate is difficult to take place. Similarly, the system is also a ring, therefore the Fn1 product will be a major and this one will be a minor. Similarly, elimination reaction will also be a minor. Just check out one last example in which the starting material generates 2 substitution and 2 elimination reaction. Again, the base is methanol, so elimination product will be minor, and the substitution product in which the ring has expanded will be a major, so this will be a major. Now we will focus on those rules which we are talking about, that how we'll decide about an elimination reaction or substitution reaction, or which product will dominate the reaction. Let's focus on those rules, but before addressing those rules, I am giving an example. Again, I am treating with sodium hydroxide, different substrate, and then predicting the product. Here I have 3 different reactions in which the reaction medium is same, facilitated by sodium hydroxide, but the starting substrate is different. The first case is primary alkyl halide, in second case we have secondary alkyl, and in third case we have tertiary alkyl halide. As hydroxide is a good base and good nucleophile, therefore it will facilitate Fn2 reaction in the first phase, where we will also get an elimination product as well. So Fn2 will be major and this will be minor. So we will get Fn2 product here in this case. As far as the second case is concerned, here the substitution or Fn2 product will be minor, because secondary alkyl halide are sterically hindered, that prevent the smooth execution of Fn2 reaction. Therefore we will get the elimination product as major. In the third case, there is no chance for Fn2 reaction, so we will get an elimination reaction. In the first case, if we want to get elimination product dominant, then we will use a bulky base. For example, and the bulky base could be DBU, DBN, or we can have diisopropyl. I mean, there are different bulky bases which can be used for getting the elimination product dominant. Now we will study 3 rules that will help us in deciding the prediction of substitution or elimination product. The first rule, one is about substrate and nucleophile. Rule number second is about, here we have base or nucleophile, substrate, and rule number 3 about stereochemistry. So let's first focus on the first rule. I am presenting here a table where I have enlisted different bases and nucleophile in 4 different columns. So this is column number first, column number second, third, and 4. So in first column I have enlisted strong bases and weak nucleophile such as sodium hydride, DBN, and DBU. These are all strong bases, and we know that strong bases promote E2 type of elimination reaction. So under this column we will get E2 type of elimination reaction. As far as the DBN and DBU are concerned, they are 2 bulky bases. Here I have shown their structure. Just check out how it abstracts proton from the acid for giving a resonance stabilized structure in which the positive charge is delocalized over 3 atoms, 2 nitrogen atom and 1 carbon atom, and these reflect a quite strong and stable situation. So under first column we have enlisted strong bases that will promote E2 elimination reaction. As far as the second column is concerned, here we have hydroxide, methoxide, and ethoxide that act as both strong base and strong nucleophile, and therefore they will both facilitate substitution and elimination reaction. As far as the third column is concerned, we have different weak bases and strong nucleophile such as iodide, bromide, and chloride, sulfide, thiols, and hydrogen sulfide. These all act as a weak base but strong nucleophile, therefore it will facilitate substitution reaction. And as far as the last column is concerned, these reagents usually act as a solvent that promote either E1 or SN1 type reaction, because we know that they are not strong bases. If they are not strong bases, so definitely they will not facilitate E2 type of reaction, and if they are not strong nucleophiles, so definitely they will not promote any SN2 reaction. So the only possibility with this reagent is of substitution nucleophilic unimolecular or SN1 or E1 type reaction. So the identity of bases or nucleophile is very important for predicting the nature of the product. For example, if we have a strong bases under first category, definitely we will point out E2 product as dominant. If we have bases or reagent from the second category, so we could have a chance of both substitution and elimination reaction. And as far as the third category is concerned, we will get substitution product, and for fourth column we will get E1 or SN1 type reaction. Now let's consider on the second rule, which is about substrate, and here we have categorize primary, secondary, and a tertiary substrate. On the strong bases are first category. This again, let me call it 1, 2, 3, and 4. So under strong bases I will get elimination product through E2. In second category, for primary alkyl halide I will get a dominant product of SN2. For secondary alkyl halide I will get a dominant product of E2, and for tertiary I will just get E2, because the reagent I use for a particular reaction is strong bases besides strong nucleophile. And as far as the third category is concerned, if it includes strong nucleophile, therefore primary alkyl halide will facilitate SN2. Similarly, secondary will also facilitate SN2, and tertiary will facilitate and SN1, because in this category we have weak base but strong nucleophile. And for the last category is concerned, both at primary and secondary alkyl halide will generate an unstable carbocation, therefore they will not facilitate any reaction. Only the tertiary alkyl halide will give SN1 or E1 type of reaction. So this is rule number second. And as far as the third rule is concerned, that is about stereochemistry. So we know that in substitution reaction such as FN1 we get racemic mixture. In FN2 we get inversion of product. For example, if we have the starting material of R configuration, so in the product we will get an S configuration molecule. And as far as E1 and E2 are concerned, in both cases we get ZU product, which reflect a highly substituted alkene. Beside E2 is regioselective. Similarly, E1 is also regioselective. E2 is regioselective, stereoselective, and stereospecific. From regioselective we mean that where the double bond will form, usually a highly substituted double bond will predominate. And as far as stereoselectivity is concerned, we will get different stereoisomers such as cis and trans will dominate the product side. And as far as stereospecific reaction is concerned, these type of E2 reaction usually observed in those cases where we have only one beta hydrogen and we get only one product for the starting material of one stereochemistry and another product for the starting material of another configuration. So this is all about the three different rules which help us in deciding which product will be formed. Here I am going to write some examples so that we could realize the significance of all these rules. The first example is and I react in the presence of NaFH. As the HF acts as a strong nucleophile, and the substrate is also secondary, so an SN2 type product will be formed. Not E2, because this species is a weak base. Similarly, another example, again the base is quite strong, therefore it will facilitate elimination reaction rather than any substitution reaction. Similarly, we have another example, which is the tertiary iodide, and it is going to react in the presence of sodium hydroxide water as solvent, and we will get elimination product rather than substitution because it is tri-substituted alkene. Another reaction in which I use tertiary butoxide as a base, therefore it will give alkene like this. Because the base is quite bulky, therefore it will abstract the terminal proton. And as far as this example is concerned, where I use sodium methoxide that acts as a strong base, so substitution reaction will not take place at tertiary alkyl halide, therefore elimination reaction will be generated and this product will be dominant. Similarly, one last example. Br, and again I am using tertiary butoxide, so it will abstract the only terminal proton because the base is quite bulky, and we will get the alkene like this. As far as CN is concerned, cyanide, it is a weak base but good nucleophile, and it will facilitate SN2 type of reaction. For example, if we have a substrate like CN, then substitution reaction SN2 will be dominant because it is good nucleophile but not a good base. So to summarize, these are some bulky bases which we can use in different elimination reactions such as tertiary butoxide, diisopropylamine and triethylamine. We can also use dimethyl pyridine. So to summarize the rule, we talked about rule number first that deal with different bases and nucleophiles such as strong bases and strong nucleophile, weak bases and strong nucleophile, and weak bases and weak nucleophile. For the first category, we checked out it facilitates E2, and the second category it facilitates both substitution and elimination, and the third category substitution, and the fourth category FN1 and E1 type reaction. Second, we talked about substrate in rule number 2, where we had primary, secondary and tertiary alkyl halide, and we checked out different example where substitution or elimination reaction will take place, and in the end we talked about stereochemistry in rule number 3, in which, for example, this material is undergoing in the presence of a strong base, and we get a major trans product rather than a cis or a terminal or any substitution reaction. I hope the video has clarified your concept about how will you decide about substitution or elimination product. Thank you for watching the session.